Hello everyone, I am glad to share with you the main result from a new publication in remote sensing of environment about magnitude 7.7 Jamaica earthquake occurred on 28 January 2020. This earthquake was located completely in ocean with a mainly strike slip focal mechanism. The ocean depth at epicenter location was about 5,000 km, and this is one of the first earthquake in our analysis that is focused on ocean earthquake. It's very interesting then to compare with other cases in land, like for example Lucian earthquakes, or mixed case like Indonesia, magnitude 7.5 occurred in 2018, which was inland but surrounded by sea. Or also the very recent publication about Haiti earthquake that occurred around this place on 14 August 2021, 1 year and a half after this earthquake, in more or less the similar area and very similar focal mechanism with respect to this one. In this paper we investigate lithosphere, atmosphere, ionosphere anomalies. Here I show you the investigation of a swarm free satellite magnetic signal, and we used two areas. One is the earthquake preparation area defined by the Dobrovolsky equation, which is one of the possible equations to define earthquake preparation area and scale exponentially with the earthquake magnitude. Then we use the second area as a comparison area, which is at the same magnetic latitude with more or less the same percentage of land and sea inside the area, but at a different longitude and in the same hemisphere. So this one is on the west coast of Africa. And then we compare the cumulative of the anomalies from swarm Alpha, Bravo and Charlie in epicentral area and in the comparison area. When we identify the first increase of anomalies in epicentral area, we may think this could be the first sign of the earthquake preparation phase. But when we see that this increase is identified exactly at the same time in the comparison area, we exclude that this increase of anomalies is produced by the earthquake. The strength of this approach is not only to extract anomalies, but discriminate which anomalies could be more likely due to the earthquake preparation area and the other one that are not due or are not likely due to the seismic event preparation. And in fact, if we see 50 days before the earthquake, this is also a particular time for Jamaica, because at this time there is the only foreshock recorded on the same segment fault responsible of the incoming earthquake. At this time there is an increase of swarm magnetic anomalies detected only in earthquake preparation area. There are no anomalies detected in the comparison area. So this group of anomalies are more likely due to the earthquake preparation of Jamaica. And here we see a difference between the cumulative recorded in earthquake preparation area minus the one in the comparison area. As you see, this one shows clearly that from about 2 months before the earthquake, from 1 month before the earthquakes, there is a higher number of anomalies detected in earthquake preparation phase, so maybe due to this source. About ionosphere, also the electron density has been investigated, and we used the data from China's seismoelectromagnetic satellite combined with the swarm Bravo, which fly more or less at the same altitude. It's wonderful to identify about 40 days before the earthquake occurrence of a clear increase of electron density. This is detected both by CSES and Swarm Bravo. And the first good news is that the profile of electron density, latitudinal profile, are very similar, so the data looks readable. But which is the possible link with the earthquake? In this case, we see that there is also a second peak, which is outside the Dobrovolsky area. But if we look at the single track, we saw that this peak has been detected only by Swarm Bravo satellite. And an important difference that we need to take into account is that Swarm Bravo was flying at about 4 AM local time, while CSES is flying at 2 AM local time. Both are night time, but this 2 hours of local time of difference could make an important role. So there are two ways of read this result. One is that there are two peaks of electron density, one bigger inside the Dobrovolsky area and another smaller outside. In this case, the hypothesis that this peak is produced by the earthquake is less likely. But the second way of read this result is that this main peak is produced by the earthquake, and 2 hours of local time after this peak migrates north-west side of the epicenter, so it is detected only by Swarm Bravo that fly in the area after with respect to the China seismomagnetic satellite. And in this case, this peak could still be due to the earthquake preparation phase, and it's at the same time we detected the similar peak before magnitude 7.5 Indonesia 2018 earthquake, and also more or less at the same time of Ridgecrest magnitude 7.1 2019 earthquake occurred in California. That case was about 53 days before the earthquake, so a shorter anticipation time, but was also a smaller magnitude earthquake. This one is a 7.7, Indonesia is a 7.5, so more or less the same. Ridgecrest was smaller and also a smaller anticipation time, in agreement with Rikitagen law that predicted that the anticipation time is longer for higher magnitude event. And now we are going to see a cumulative result of lithosphere, atmosphere and ionosphere before Jamaica magnitude 7.7 earthquake. In particular, we see the Benioff stress in red, the cumulative of ES parameter in blue. ES parameter is a value that divides the energy of an earthquake for the square kilometer distance to the incoming earthquake, which is Jamaica in this case. And in this curve we see the cumulative of atmospheric anomalies, and here the cumulative of ionospheric anomaly from Swarm and CSES. All of these curves are calculated in 6 months before Jamaica earthquake, so we can compare each other and search for possible propagation of anomalies from one layer to another layer, or important moments. For example, this one, it's a little increase of seismicity detected 130 days before the earthquake. Then there is 110 days before Jamaica earthquake, an important increase of SO2 anomalies, which we will see more in depth after. And the third increase is the one that we just saw in the other picture about swarm magnetic anomalies and also some of CSES. And it is interesting to note, for example, that this increase of anomaly has been preceded by an increase of seismicity in lithosphere, so this could underline a lithosphere ionosphere coupling without some anomalies detected, at least by this method, in atmosphere. But the final trend of increase of seismicity before the earthquake is very similar to the final trend of atmospheric anomalies, suggesting a lithosphere-atmosphere coupling, or better, that the atmospheric anomalies could be due for the degassing and other processes in the final stage of preparation of Jamaica earthquake. And now we are going to see what happened from a few seconds before Jamaica earthquake until its occurrence and even some minutes after. Because in this case we had a very lucky combination. China seismic electromagnetic satellite at the time of earthquake occurrence was flying at the longitude of the earthquakes and 10 minutes after was flying exactly above the epicenter. Also Swarm Bravo was flying from south to north before the earthquake occurrence. And 7 seconds before Jamaica earthquake occurrence, electric field detector on board the CSES detected this very interesting M-shaped signal. It's possible to see that a similar signal is detected in Swarm Bravo in 50 Hz magnetic data, and there is a good correlation between the two data. The time this signal starts is a little different for CSES and Swarm, but if we see the angular distance of these two satellites with respect to the incoming earthquake, we can use this difference to calculate the propagation speed of this signal, supposing it is the same signal produced by the same source, and so the earthquake. And it's possible to find that the propagation speed is about 200 km per second. This speed is the speed of propagation of ion in inner Van Allen belt, so at this altitude. So we supposed that the nucleation of the earthquake, which is the micro crack start of formation before the main rupture, induced the electromagnetic wave, which takes about 1 nanoseconds to propagate to ionosphere, and then ion drift propagates toward CSES and Swarm Bravo on the other direction. At earthquake occurrence also we identify a very interesting signal on China seismic electromagnetic satellite flux gate magnetometer. This signal is detected 30 seconds after the main release of seismic signal. And if we calculate the propagation speed, it's the same magnitude order of the previous one, about 150 km per second, suggesting also that the rupture of the earthquake produced the electromagnetic wave that induced an ion drift that was detected by China seismic electromagnetic satellite. Finally, after the earthquake occurrence, we can see some interesting magnetic anomalies detected both by China seismic electromagnetic satellite in black and Swarm Alpha and Charlie in blue and green, and the signals are very similar to each other, suggesting a perturbation of the ionosphere magnetic field detected by both satellites. And also we note that this signal is detected when the satellite passes exactly above the epicenter, suggesting that this could be induced by a fault assessment after the earthquake, because it's 10 minutes after the earthquake. And it's also confirmed by ground observatory, and that detect also similar perturbation exactly at the same time of CSES satellite, and the only propagation mechanism compatible to propagate vertically in 500 km and horizontally at about 2000 km in Geomagnetic Observatory in US is an electromagnetic wave. So it suggests that ULF, ultra low frequency electromagnetic wave, was detected as a fault assessment by ground and satellite magnetic observatories. Another important result of this paper is shown in this figure, where we compared the lithosphere result with the ionosphere electron density measured by China seismic electromagnetic satellite CSES-01. In particular, we noticed that anytime the parameter ES increased, from 1 to 5 days after, the electron density measured by China Seismo Electromagnetic Satellite is increased also and anomalous. We also noticed that the order of the intensity of the electron density anomalies is the same as the energy ES of seismicity. In fact, this is the highest increase of electron density, which corresponds to the highest value of ES parameter a few days before. And this is the second, and this is the second values for seismicity, the third one and the fourth one. So the same sequence of intensity of anomalies. We also notice that one anomaly of electron density is not associated with any increase of ES seismicity, but this electron density anomaly is the smallest and it is just above the threshold. So technically it is an anomaly, it is a false alarm, but it is the smaller. So that means that it seems that anytime there is an increase of seismicity, the ionosphere with the time between 1 and 5 days responds to this increase of seismicity as an increase of electron density content, suggesting a couple between lithosphere and ionosphere. Another interesting possible coupling detected studying the Jamaica earthquake is the one we present with this figure, where we summarize several things and also we provide a possible mechanism of coupling between lithosphere, atmosphere and ionosphere. So we supposed that the increase of stress at earthquake epicenter make release some gases that transmit through the geological layer at the coast of Jamaica and Cuba, degassing some SO2 in the air. In fact, in the picture you can see the SO2 that is highest on the coast of Jamaica and a little higher also in the coast of Cuba. And we also found an increase of temperature at the coast of Jamaica, exactly at the same place of SO2 degassing. Then, comparing the swarm magnetic data, it's identified a particular anomaly that is exactly at the same L shell, so of the Jamaica coast, of the pixel with the highest SO2 value. This means that the gases in the atmosphere could have produced an ionization as predicted by Poulinets and Dodznov, and then following the magnetic line as modeled, for example, by Kuo et al. JGR 2014, it could have produced an ionospheric anomaly at the same magnetic latitude. And this so could be a full chain of lithosphere, atmosphere, ionosphere coupling preceded the Jamaica 7.7 earthquake. The final picture of the paper is this one that summarizes the space and time organization of all the anomalies. So we can see that the space organization is not casual of these anomalies, further supporting the concept that probably they could be related to the preparation phase of this larger quake, or at least someone. In fact, we notice that, for example, the aerosol is aligned with the fault line, as well as the outgoing long wave radiation, which is larger but also well aligned with the seismic setting. And also the electron density, as we saw in the previous picture, here just summarized several months before, was increased inside the Dobrovolsky area. So there seems to be a space and time organization of the anomalies along the tectonic settings, and also starting from more far, and the one that are closer to the epicenter tends to be more on the tectonic system where it is the Jamaica earthquake, not exactly close to the Jamaica epicenter, but they are aligned well with the tectonic system, so also in the previous or following faults with respect to the one responsible of this earthquake. So I invite you to read the full paper, and if you have any question, please don't hesitate to contact me or the other co-author. We will be happy to answer to your question. Thank you so much for your attention. I wish you an absolutely wonderful day. Bye bye.